In this video, we're going to talk about evaluating functions. In this video, we're going to talk about evaluating functions. Remember our function notation, f of x is equal to some function rule. So we're going to look at several examples. In this video, we're going to talk about evaluating functions. So given a function like f of x equals 3x plus 5. To evaluate this function, what this is telling me is that this is my x, so x is equal to 2. And what I'm going to do is I'm going to replace the x with whatever value is in here. So we get 3 times 2 plus 5, or f of 2 is equal to 11. We can plug in -1. You see how I use the parentheses when I am plugging values in? It just eliminates a lot of mistakes that can be made with negatives. So f of -1, we get -3 plus 5, or 2. Now we can plug anything in. We've got 2 other variables that are being plugged into this function. We're going to do the same thing we did on the previous examples. We write our function out again. We're going to replace that x with parentheses, and we drop in whatever value is here. So in this case, it's the a plus b. Now we have to simplify. So what we get is 3a plus 3b plus 5. So that's after we distribute that 3. Last one, same thing. We take the 3, we replace the x with parentheses, and we finish it up with the plus 5. We're going to plug in the x squared minus 1. Again, we need to simplify, we need to distribute, so we get 3x squared minus 3 plus 5, which again simplified would give me 3x squared plus 2. We're going to look at another example. We got an absolute value function here. Remember, absolute value means distance from 0. So when we plug in this value, we're going to replace that x with the value in the parentheses there. Simplifying, we end up with -50 minus 100, which is -150. But because of the absolute value, we interpret that as distance from 0 is 150 units. Same thing here, absolute value 5, plugging in the 1, minus 100. So we get 5 minus 100, or -95, inside that parenthesis, inside the absolute value. And the absolute value of -95 would be +95. Following the same procedure, I'm going to substitute whatever's in the parentheses for the x, and then simplify. So simplifying, multiplying a fraction by our denominator gets us the numerator. So we end up with the absolute value of x minus 100. And there's nothing more we can simplify there. We go to our next example. it's similar. What it's doing though is giving you the end result, and you have to find what X was plugged in. So what we're looking for is what is the value of the X in here that yields this 9. So what it's saying is 9 is going to be equal to 2x minus 3. What is the x? So we simplify. We solve. We find out what is the x. So 12 is equal to 2x. We divide by 2, and we get x is equal to 6. We can double check that. If we look at f of 6, what we're going to do is we're going to substitute the 6 for the x, giving me 12 minus 3, which is 9, which is what we were looking for. A couple more examples. Just to go over some things that we might have forgotten over the long summer. When we substitute for the x, we're going to replace just the variable with the parentheses. So everything else in that function looks the same. We've got the squared here, we've got the 2 in front of the x, and we're going to plug in that x plus 2. I didn't leave enough room for myself here. X plus 2. Squaring this, remember we have special cases. A plus b quantity squared is going to be equal to a squared plus 2ab plus b squared, where in our case here, the x is the a and the 2 is the b. So we end up with x squared plus, multiply these two together, 2 times x times 2 again will give me 4x, and squaring the 2 gives me 4. Minus, we're going to distribute this negative 2 to both of these terms, giving me a negative 2x minus 4 plus the 1. Simplifying, my 4's are going to cancel. I end up with x squared plus 2x plus 1. Now, this one throws people all the time, and it's just looking at the points on the graph. So when you're looking for f of 5, this graph here is f of x. So the graph represents all of the ordered pairs that are in that function. So if the x is 5, that's here. X is 5 here. You're going to go up until you hit that function to find what that point is. I put in the points because I still don't know how to put graph paper on here. So if my input is 5, my x, my output is going to be 4. Another way they can look at this is when f of x is equal to 1. So that means when f of x is equal to 1, that's my output. My 1 is my output. So y is equal to 1. I'm going to go through and look at, okay, so here my y is equal to 1. What x's give me that? I give this one. So x can be negative 5, but it also hits the y here. So my x can also be positive 2. That's it for the evaluating functions.